So our first question asks us to consider the curve y equals x to the power of 3 minus x squared minus x plus 3. Question I says, find the stationary points and determine their nature. So what I've started off with is finding the first and the second derivative. And the next step is to find the stationary points. So you start with the first derivative. And you make it equal to 0. And then you solve for x. And these are the x coordinates of our two stationary points. So the next step is to find the y values of these stationary points. And to do this, we sub the x values into the original equation. And in this instance, x equals 1, so you put 1 where all of the x values were to find the y. So our first stationary point is 1, 2. And next you do it with your second stationary point. Plug it into your calculator, and you've got your second stationary point. Next up, we test the concavity, and you do this by putting the x value of your stationary point into the second derivative. So with our first stationary point, we put 1 where the x values are. And this gives us 4. And because 4 is greater than 0, we know that it is a minimum point. Next we test our second stationary point, also by putting the x value into the second derivative. Subbing it in. And because the answer we got was less than 0, we know that the point is a maximum point. Now we have the second part of our question, which says, given that the point P, 1/3 and 70/27 lies on the curve, prove that there is a point of inflection at P. So what we need to do here is test the concavity of P, which you do by putting into the second derivative, and because it's equal to 0, you know that there is a possible point of inflection. So now we need to test the concavity. By putting 0 where the x values are. And because it's greater than 0, then you have one side is concave up, and then you put 1 into the equation, and because it's equal to 4, and it's greater than 0 and it's concave down, so therefore the concavity changes, and you know that P is a point of inflection. And the last part of the question is to sketch the curve labeling the stationary points, point of inflection, and y-intercept. So now we're graphing. First you have to find the y-intercept by making x equal to 0. Put your x and y axes. Label your numbers. Put your first stationary point, P, y-intercept, and your second stationary point. And now you can draw the curve. Write down your equation. And we're done. So for this question, a rainwater tank is to be designed in the shape of a cylinder with radius r meters and height h meters. The volume of the tank is 10 cubic meters. Let A be the surface area of the tank, including its top and base, in square meters. And the first part of the question says, given that A is 2 pi r squared plus 2 pi r h, show that A equals 2 pi r squared plus 20 over r. So we know that the volume equation is volume equals pi r squared h, and we've been given that the volume is 10. So therefore 10 equals pi r squared h, and rearrange the equation for h as the subject. So now that we have a value for h, we can sub it into our initial equation for A, the area. Where the h is, you sub in that equation we've got at the top there, and from there you can cancel out the values that aren't needed, multiply the 2 and the 10 together, and that gives us A equals 2 pi r squared plus 20 over r, which is what we needed to prove. Therefore, we've proven that A equals 2 pi r squared plus 20 over r. The second part of the question shows that show that A has a minimum value and find the value of r for which the minimum occurs. So first things first, we need to differentiate our equation. And next, we find r. And you do this by making the first derivative equal to 0, because a value is maximum or minimum when the first derivative is equal to 0. With our new r value, we find the second derivative and plug r into the equation. And from that, we know whether the value is minimum or maximum by whether it is greater or less than 0. And because our value is greater than 0, we know that A is minimum when r equals 1.17. And we do this by putting in, how do you do this? What the hell?